નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Hello students, today we will study the second important topic of standard 10, chapter number 1, real numbers, and the topic is the fundamental theorem of arithmetic. Okay, first of all we will understand this theorem. Then we will study what is the application of this fundamental theorem of arithmetic. That means using this fundamental theorem of arithmetic, what type of question we can solve, that we will study later. Okay. Before understanding this fundamental theorem of arithmetic, let us clear some of the things that we have already studied in previous standards. And that is, if we have numbers, let's take positive integers, then that numbers are of, we can divide that into two categories. One is the composite number and second one is the prime number. Okay, so which number we can say as a composite number and which number we can say as a prime number? See here, if we take number 6, then what will happen? If we factorize this 6, what we will get? 3 2s are 6. Other factors we get 6 1s are 6. Let us consider 9. 9 we can write down as a 3 3s are 9 and 9 1s are 9. Right? What is the meaning of factor? That you have now clear in your mind, that number by which we divide the 6. The number by which we divide the 6 and the remainder becomes 0, then that number is called the factor of 6. So here 6 is a factor of 6, 1 is a factor of 6, 3 is a factor of 6 and 2 is a factor of 6. How many factors we get? 4 factor we get here. Similarly, 9 is a factor of 9, 1 is a factor of 9 and 3 is a factor of 9. So how many factors we get here? 3. Okay, so number of factor we get here is more than 2. Whenever we get the number of factor more than 2, that number becomes composite number and that number is called the composite number. Which number is called a prime number? See, take an example of 5. If we factorize it, we can write down is a 5 1s are 5. Other factors is not possible. By taking 7 we get the 7 1s are 7, by taking 3 we get the 3 1s are 3, and by getting 2, by taking 2 we can factorize is a 2 1s are 2. So in all these numbers there is no other factor than this number, than these two factors. So maximum number of factors we can get here is only 2. So the number which has only 2 factors, that numbers are called the prime numbers. And which are the two factors? One is number itself and other factor is 1. Right? Number itself and 1. So whenever we get only 2 factors of any number, that number is called the prime numbers. Whenever we get the factors more than 2, that numbers are called the composite numbers. Right? This you know very well, but to understand the fundamental theorem of arithmetic, these two things we have to revise. That is why I have taken this topic. Now what is the statement of the fundamental theorem of arithmetic? Statement is, that is also called as theorem 1.2. Before this, let's take one more example, 56. If we factorize 56, then we will get 2 into 2 into 2 into 7. That means 2 2s are 4, 4 2s are 8, 8 7s are 56. We can also write down it as 8 multiplied by 7. But whenever we write down the factors in the terms of prime numbers, then it is called prime factorization. Right? Like here also we can write down 6 as a 6 1s are 6. Yes, 6 and 1 are also the factor of 6. But they 6 and 1 are not called the prime factorization. When we write down it as a 3 2s are 6, then this 3 and 2 are the prime numbers then this factorization is called the prime factorization. So here the factorization of 56 we can write down in this way, and this way of factorizing is called the prime factorization. That means whatever the factor we get of 56, all the numbers must be a prime number, right? So this is the prime factorization of this 56. Now we will see the statement that is also called as theorem 1.2. Every composite number can be expressed in the sense can be factorized as a product of primes, as a product of prime numbers. So here we have seen that 56 is a composite number because it has more than two factors, can be expressed or factorized as a prime, as a product of prime. So this is the product of the prime numbers. All the numbers are prime and all the numbers are in the production. So this factorization is unique, right? This factorization is unique. That means no other prime factorization we get other than this, right? We cannot get 3 in the factorization of 56. We cannot get 5 in the factorization of 56. We cannot get 11 in the factorization of 56. We get the prime factors whenever we factorize 56. We get this 2 3 times and 7 1 time. One more thing given in the theorem statement is the prime factors are must unique and apart from the orders. That means the prime factors may be in different order. That means we can write down 7 as the first position, then 2 into 2 into 2. That is also the same kind of factorization. We just change the place of 7. So this is according to this apart from the order, right? That means order may be changed, but the prime factorization remains the unique. We get that 2 3 times and 7 1 times, that we will get all the times whenever we factorize 56. Whenever we factorize 56 as a prime factor, right? Okay. So this is the statement of theorem 1.2. Okay. And this is the uniqueness of the fundamental theorem of arithmetic also, that we get the factor of any composite number in this manner and that factorization remains the unique. Okay, so this is all about the fundamental theorem of arithmetic. Now we will study the application of this theorem. Okay, so what is the first application? First application of fundamental theorem of arithmetic is to find the LCM and HCF. LCM is stand for least common multiplier and HCF is for the highest common factor. To find out both this, we can use the fundamental theorem of arithmetic. Okay, let us take an example and understand this thing. We have two numbers 510 and 92. Okay, so if we factorize 510, we get the prime factors. Remember one thing, now we have to factorize any number in the prime factors only. Then only this fundamental theorem of arithmetic can apply. So by 510, if we factorize this 510, we will get 2 into 3 into 5 into 17. 2 3s are 6, 6 5s are 30 and 30 into 17, that is equals to 510. Okay. Now 92. 92 we can factorize as 2 to the 4 and 4 into 23. 23 4s are 92. Okay. So here 2 is only one time, that is 2 raised to power 1. 3 is also one time. All these factors are one time only, that is why all the numbers as one power. But in this 2 is 2 times, that is why we can write down it as 2 raised to power 2 into 23. Okay. Now what is the HCF? Highest common factor. Highest common factor we can write down it as product of all the common factors between the two numbers, and that common factor we have to take which has a least power. Product of all the common factor with least power, right? So which is the common factor between these two numbers? 2 is the common factor, and least power means minimum power. Here 2 has to 1 power and here 2 has 2 power. So we have to select 1 power, and this 1 power we have selected. Is there any other number which is common between these two? No. No other factor is common between these two numbers. So this 2 will become the highest common factor of both this number. Right? Okay. What is the LCM? LCM means product of all the factors with maximum power. Product of all the factors with maximum power. If we have two same factor, then we have to select that factor which has the maximum power. Okay, let us understand. Here 2 is common in both the numbers, but here 2 has a 1 power and here 2 has a 2 power. So we have to select the number which has a maximum power. So we have to select 2 raised to 2. Right? Okay. Now 3, here there is no 3. So this will be selected as a maximum power because 3 has 1 power and no other 3 is here. So we have to select this 3 also. 5. 5 is also 1 time and that is the maximum power. We have to select 5. 17 is also with the 1 power, that is maximum power, 70. 23 is also with the 1 power, so we have to select 23. So production of all these factors with maximum power gives us the LCM. So by doing the multiplication, we will get 23,460. So we can say that LCM of 510 and 92 is 23,460. Okay, one more time, what is HCF? HCF is the product of all the common factor. Remember this thing, common factors only we have to select, and that common factor also with the minimum power. So here 2 is the common factor and the minimum power is 1. That is why we select only 2. And HCF, LCM is what? LCM is the product of all the factors, not common, all the factors with maximum power. So here we select, that is why we select 2 raised to 2, right? Okay. So this is all about the HCF and LCM. And to represent LCM and HCFs, this is the method. Write down HCF and in the bracket both the numbers. And the value of HCF we can write down in this way. Also LCM we can write down in this way. LCM of both this number is 23,460. Okay. One more thing here we have to study is whenever we multiply both these numbers, given numbers, let's take it as a and B. Then in common way we can say that HCF of two numbers and LCM of both two numbers. When we multiply the HCF and LCF of both the LCM of both the numbers, then the value we will get is equals to the product of both the numbers. Right? So let us understand this thing with this example. HCF of both this number is 2 and LCM of both this number is 23,460. The total of these two numbers multiplication HCF and LCM, we will get the equal value of the two numbers production. Right? This product you can do yourself and check that right hand side value, left hand side value and right hand side value will become the equal. You can check by taking any other examples also. Right? One more thing we have to remember is this method is only applicable for the two numbers only. This is not applicable for the three numbers. That means if we have three numbers, we find the HCF of three numbers, LCM of these three numbers, then it would not be equal to the product of three numbers. It is not applicable for the three numbers. It is only applicable for the two numbers. Right? So how many numbers are there? 1, 2, 3 and 4. So out of this 4 number, if we have given 3 numbers, then we can find out the fourth one. Like if we have given the two numbers and LCM, we have to ask to find out the HCF. Then by putting these three value, we can find out the HCF. If we have given the HCF and LCM of two number, and out of these two number only one number is given, then we can also find out the value of B. In this way, out of 4, if any number is missing, we can find out by this formula. Okay, so this is the first application of fundamental theorem of arithmetic to find out the HCF and LCM. Now, second application. To understand the second application, let us take in the sum that is of exercise 1.2 question number 5. And what is the question? Question is, if we apply the 6 raised to n power, then for any value of n, can we get a number which end with 0? That means, suppose if we take 6 raised to power 3. So, by doing this, can we get that number 6 cube which has a last digit as a 0? So, we have to find out such value of n, so that by applying that value of n, we get the result which has end digit is 0. Okay, so to understand this thing, first of all, which number we have which has 0? First number with the 0 is 10. Before that we get the 9, 8, 7. So before 10 we cannot get any number which has last digit as a 0. Yes, there is a 0 is there, but we cannot factorize 0. So we have to select the number which we can factorize. Okay, so the first number which has a 0 as the last digit is 10. And what is the prime factorization of 10? The prime factorization of 10 is 2 into 5. What is the second digit which has end with 0? That is 20. If we factorize 20, we get 2 2s are 4, 4 5s are 20. Notice one thing, to have a last digit as a 0, in the prime factorization of the given number, there must be two numbers, 2 and 5. 2 and 5. You can also check for the 30, 40, 50, 60, 100, any numbers which end with 0. They must have two factors, at least two factors, these two and 5. There must be in the prime factorization of that number. Now what will happen if we factorize 6 raised to n? By factorizing 6 raised to n, we will get the factors of 6 as a 2 into 3. 2 3 is 6 and power is n. Okay, so there is no 5 as a factor. Yes, there is 2. To have a last digit as a 0, there must be two factors, 2 and 5. But here only 2 is there. 5 is not there. So by taking any power of n, we cannot get the 0 as a last digit. Okay, so no value of n is possible. That is the answer of this question. So why? Because according to the fundamental theorem of arithmetic guarantees this thing, that there is no other prime factorization of 6 raised to n is possible except this. This is the uniqueness of the fundamental theorem of arithmetic, right? We cannot get any other prime factors except this. Whenever we factorize 6, we get 2 3s are 6. And so, according to this fundamental theorem of arithmetic, there is no value of n is possible such that by applying this power of 6, we get a digit in which the last digit is 0. Okay? So, this thing is also applicable for any number like 4 raised to n. If we have given 4 raised to n, then the factors of 4s are also 2 into 2. There is also no 5. So, for 4 raised to n, same thing will apply. For 9 raised to n, this same thing will apply. For 8 raised to n, this same thing will apply. So this kind of sum we can solve by this fundamental theorem of arithmetic. Okay? So this is all about this lecture. Okay? Thank you. Thank you for joining us.